Christian is here again to give you another tutorial with composite optimization. Now, I'm carrying on from the previous tutorial where we went ahead and gone through this exercise of crafting different ply shapes. We then went ahead and performed this ply number optimization. And in this workshop, what we are going to do is perform a stacking sequence optimization. There are various manufacturing rules that you have to follow before you go ahead and settle on a final composite. And again, in this tutorial, we're going to go ahead and perform that stacking sequence optimization. Now, I'm going to carry on from the previous tutorial, which has a composite that is slightly different. So when you follow this workshop document, just know that it's not going to be exactly the same with the files that I'm working on in this video. But just know that we are going to start from this composite that looks like this, and we're going to end with a composite that might look like this here on the right. So now it's the same analysis model as before, same starting P comp, and here as always, remember, if at any moment you have a question, maybe you want to start using the same tools I'm using here today, here's my email address. Feel free to reach out to me and I'll make sure you get a reply as soon as possible. Now, let's see. Before I go ahead and get started with this tutorial, let me mention that the appendix will have a lot more information that I'm going to skip in this presentation. So I definitely encourage you to take time after or before this video to go through the appendix, just so you have this background information that will help you better optimize composites later on. Now, let me minimize everything. And like I said, I'm carrying on from the previous ply shape and ply number tutorial, so I still have all those windows open. Let me go ahead and start closing some of these windows. And I think I'll only leave this window, which is showing you the ply thickness or the plies from the previous workshop. Let me go back to the home page. And now if you go to the list of web apps, you'll find a link to the stacking sequence web app. Let's go ahead and upload the bulk data files that we created in the last tutorial. So these files are going to be the files in directory workspace C. We'll go ahead and select those and upload them to the web app. Once we do this, we'll go to select stack and we'll select multiple stacks. Now, here you should select the gply carefully. Let me go here and let me show you what are we doing here. And let me hide all of these gplies. Let's suppose that I've only selected maybe this one. Maybe not. Okay, let me just look for a good ply here. Okay. So let's suppose that I've only selected this gply. And let me search for this gply here. Right, this might be pcom G9. Right. So if I only select that gply, it's only going to display that pcom G entry, all the plies in that pcom G entry. So let's go ahead and select gply 183001. Let's go to optimize. If we look at the table, we'll see that we only have 14 plies. And this is not good because we're only going to optimize the plies. Let's click on display additional columns. If we do this and toggle the displays, if we only select that gply is only used in pcom G9 and pcom G10. But this is not what we want. We want to optimize the stack for all the different pcom G entries. So here, we want to select a bigger gply. So that's why we've selected gply 111000. So here, if I go back to the stack and then I select gply 111000, I think before we had 14 plies in that one. And here, let me go back here. And let me display all the columns. Right. So now here, whereas before we were only dealing with a PCOM-G 9 and 10, when we select the bigger ply, if you will, we're now optimizing PCOM-G2, PCOM-G3, 4, 5, and so on and so on. So just to summarize that little explanation, pick the largest ply shape. So you can pick the maximum number of PCOM-G entries. And here, if we scroll through this, you see that we have all these different PCOM-G entries loaded and will be updated during this optimization. You can click on this compact mode, and now you see that the columns have been reduced. They're more narrow. You can click on toggle display plies, so you can see where the plies exist and where they don't exist. And now let's go ahead and actually hide this and start working on the optimization. So the first thing is first, let's suppose that we want to pair the 45-degree plies. How do we do that? If you scroll up, there's a section here called pairing. Say yes and say perform optimization. And now we have an updated stack. Here we see that we have a positive, negative 45-degree pair, and then a negative, and then positive 45-degree pair. Maybe we don't want the order to alternate, so maybe we want the order to be the same order. So let's go ahead and use a different option. We want the order to be this. So right now the order is this: 45, negative 45, then negative 45, 45. Maybe we want to use this format where we have the same order for the pairs. We just change the order from not used to same, and we perform the optimization, and now that's what we get: positive, negative, 45-degree plies. Now let me click on display additional columns, and when we do this, and let me click compact mode to disable that, all the PCOM-G entries are automatically updated for you, and that's what you see here. So let me go ahead and turn compact mode on again. Let me just hide this for now. Let's see. Let's look at the optimized stack. You'll notice one odd thing here. The core layer has actually moved. We want the core layer to stay in the middle of this entire composite thickness. So what do? Here for the core layer, we'll just click this lock icon to fix the ply or the layer. And then we'll click on perform optimization. And now you'll notice that the core layer is in the middle of the entire stack. That's what we want. One additional thing, maybe you want the outer plies to be a certain set of angles. So as an example, maybe you want the plies to be positive 45, then negative 45, then 90, then 0, or whatever set you want. You can actually move the plies using the arrows. And then once you have the order that you want, you can go ahead and lock those plies and perform your optimization. And you'll notice that the top and then the bottom, those plies have been fixed. So now we have positive 45, negative 45, 0, and 90. Now let's work on a few additional things. Here maybe you don't want, let's see, what can we do? Maybe you don't want all these 0-degree plies to be together. Maybe you want to separate them out. And let's actually see here. Right. So here in this optimized stack, we see some of the 0-degree plies are together. And maybe you don't want to do that. Maybe you want at most 2 0-degree plies to touch. How do we do this? Here there's a box called, or a table called maximum number of consecutive plies. Here I'll specify that I want at most 2 plies. And then if we look at the optimized stack, that's what we have. At most 2 plies are together. Now, you can play with some of the options here. I'll leave it to you to experiment with these various other options. If you want more information on what these other options are, you can go ahead and refer to the workshop. And this is where I give you more details regarding the various options here in the web app. Okay, now let's go ahead and look at what the plies look like throughout the PCOM-G. Okay, things look good. Okay, things look really, really good. Okay. So here you see the 45-degree plies are together here and here. We have a 0, then a 90, then a 0, 0, then a 0, 90, negative 45, then the core layers. So this is looking like a good composite so far. Let me go ahead and click Save New Entries. And then if I go to the review section, all the necessary PCOM-G entries have been updated for me automatically. So let's go ahead and download this set. And then we'll get a new zip file. And then I'll rename this zip file for stacking sequence. So for stacking sequence. Let's go ahead and extract the contents. And as a last step, let's go ahead and make sure that we're still satisfying the constraints. So now we can rerun Nastran and perform that final analysis. And we'll look at the failure indices in a moment. And here in the viewer, I'm going to open a new viewer. And in a moment, we're going to do some comparisons between the original stack and this new stack. So let's go ahead and hide all the plies and hide all the PCOM-Gs. And maybe I'll show you the PCOM-Gs right now. Let's go ahead and look at the G-ply view. Look at this, maybe turn on the wireframes, and then maybe zoom in a little. And then for the viewer web app, we'll do that in a moment. So let's go ahead and see where we're at with all this. Okay. So we're going to upload the bulk data files from the stacking sequence directory. And we're going to compare the plies from before and after. We'll go ahead and show this. And remember, it might take a few seconds or a few minutes for the plies to be generated. So that's why you see this update here in the top left-hand corner. Let me just start preparing the view for the G-plies. So in a moment, you'll see a bunch of checkboxes here to display the G-plies. Now, oh, that's what you see right now. So we'll give that a few seconds to finish. Okay, perfect. Let's go ahead and display the ply thicknesses. Let's recolor the plies. And let's zoom in. Maybe turn off this for now. And let me zoom in. So this window is what it looks like before the stacking sequence optimization. And this is what the new set of plies looks like. So let's go ahead and see if we could see a few things. Let's see, right. So before, the outer plies were 90, 45, negative 45, and 0. But if you recall, we said that, hey, we want a specific order for the outer plies. So that's what we did here. We went ahead and said, okay, make the outer ply 45, then negative 45, 0, then 90. We paired the 45-degree plies. We separated some of the 0-degree plies. And so here we're using the viewer to look at the new stacking sequence of the plies. Now, let's look at the final Nastran validation. So we're still using the optimizer to do the the validation for us. Here we see the new objective, which is about 2.29. It's the same mass as before. We didn't remove or add plies. More importantly, what is our new normalized constraint? So here it's negative 0.21. If we wanted to, we could go to Patran. And let's go ahead and delete the old H5 file. Let's go ahead and attach the new H5 file, and we'll navigate to that stacking sequence directory, and we'll select this H5 file and click apply. We'll go to results, go to fringe, select the first subcase, select ply indices, select all the plies except the core layers, and click apply. So here we have a max failure index of about 0.75. And then since we shuffled the plies, this will change the stiffness, the bending stiffness of the composite. So the failure indices will change slightly. So if we look at the max failure index of the second subcase, we see that we now have 0.7 as our highest failure index. So let's go ahead and document all of this in the previous workshop, which I believe I did not save, but that's okay. Maybe I'll just document it here again in this example. So let's go ahead and look at the table. So remember, this tutorial is a continuation of the previous workshop. So previous tutorial and this tutorial. So if you recall in the previous tutorial, I actually have the value saved here, fortunately. So in the previous tutorial, this was the mass that we got for the entire coupon. And then the mass of the core is still the same. And then this was the new optimized mass after we did the ply number optimization and we removed the negligible plies. The mass in this example should still be the same, 2.29. And if you look back here, that's what we get, 2.29 E negative 0.5. The mass of the core, again, is going to stay the same. So your stack and sequence optimizations should still have the same weight. Now, the max failure index, I did not document that. So maybe let me do that in a moment. So here, let's look at the max failure index for subcase 1. So 0.75. And then let's look at the max failure index for subcase 2. So that's 0.7. 0.70. So this is okay also. Let's go ahead and look back at the previous workshop and look at what the failure indices were before. So I'm going to go to the downloads, ply number directory, workspace C, and attach that H5 file. We're going to go to results, fringe, and we're going to look at the ply failure indices again for the same ply. So everything but the core layers. Click apply. And the first failure index from before was 0.75. Now you'll notice that the failure index is the same. The reason the failure index is the same is because of the following. The first load case was a tension load that you see here. When you are pulling on this composite, it doesn't matter what the stacking sequence of the composite is. Whatever stacking sequence you have, you'll get the same failure index for this purely tension load. Now, for this transverse load that's causing a bending in the composite, this is where the failure index will change depending on your stacking sequence. That's why if you look back in Patran and we get the max failure index, and here I'll have to restart Patran right now, and we'll have to redo this again. You'll see that the failure index, I believe, actually, I remember what the failure index is now. I believe it was 0.975. So let me document that here. Let's see, where is that table? Here. I believe it was 0.975. And I'll open Patron in a moment to confirm that. So let's go ahead and confirm that value. And while I'm doing this, let me explain that again. So if it's a compression or a tension load, regardless of the stacking sequence, you'll most likely get the same failure index. But if you have a load that causes bending, the stacking sequence will influence the failure indices. That's why you saw for the first subcase, which is a purely tension load, you saw that before and after the stacking sequence optimization, we got the same failure index. But here, when we look at the failure index for the bending load, we actually get a different value before and after the stacking sequence optimization. So let's go ahead and look at what the final failure index was in the previous example. Let me turn off averaging. It's not something I personally like. Okay, perfect. So yeah, it was 0.975. Great, perfect. So here, let's go ahead and look at the results. So we're pretty much at the end of this entire workshop series. I'll recap everything we did in a moment, but here let me call out one important detail. You will most likely get a different composite solution, and that's okay. As long as you went from this very large composite, or mass rather, as long as you can reduce the mass, and here let's suppose this was 2.22, and then our new mass is about 1.7. As long as you reduce the mass, you have successfully followed the workflow that you've seen in this video. I know that when I started doing optimization, I was always obsessed with getting a converged solution. I was always obsessed with getting the global solution. But this is not practical. We do not have enough time to look for the best possible solution in the world. But as long as you can reduce the mass by an X amount, that, in my opinion, is a success. So when you do this workshop, don't obsess with getting a mass of 1.76. Don't obsess with getting a mass of 1.7. Again, as long as you reduce the mass by some amount and you satisfy your failure index constraints, you have successfully performed the composite optimization. And the last thing I'll say here, I think as long as you get a value that's less than 2, I think you're on the right path to following this optimization procedure that I showed in this tutorial. Now, what is there left to cover? Let me go ahead and recap this entire workshop series. So, congratulations, you made it this far in this whole composite optimization. If you look back, we went over multiple phases. In phase A, we wanted to optimize the 0 degree direction of the composite. This is important because if the 0 degree direction of your plies is not optimal, you might need more plies than necessary. If you remember back to that first workshop, I believe I needed 24 plies for the top half of the composite if my 0 degree plies were in this direction. But when I performed the 0 degree direction optimization, I reduced it to 3 plies. So remember, consider the 0 degree direction optimization so you end up using fewer plies than before. And then in phase B, perform a baseline ply number optimization. So basically in this workshop, we considered fully rectangular ply shapes for the composite. We didn't add any ply drop-offs. We didn't create these interesting looking ply shapes. This then gave us a mass of about 2.22. So that's where that mass came from, that table. This was the starting design, if you will. And then later on, we can use this mass to make comparisons on whether or not we're actually reducing the mass of the structure. And then in phase C, we were only focused on preparing the data for ply shape optimization. Basically, what we were doing, we were taking the failure indices and we were storing them in ply files. In phase D, which was the previous tutorial, that's where we introduced ply drop-offs. We created these interesting looking ply shapes. We then went ahead and performed the ply number optimization. For phase E, which was this workshop, we performed the stack and sequence optimization. And throughout this entire thing, the ultimate goal was to reduce the mass while satisfying the failure indices. So I think that pretty much sums up this lengthy composites optimization workshop. I know it was pretty long. It was perhaps one of the longest workshops I've done, but you can see that it's effective. the strategy you saw employed in this workshop was very effective in creating the apply drop-offs and minimizing the weight of your composite. Now, if you have any questions regarding the methods shown in today's presentation, maybe you want to use the tools that you saw today, you're more than welcome to contact me here at this email address, and I'd be more than glad to have a discussion with you regarding your question, your comment, or your request. So with that, I think I'll stop here, and I'll give you a big thank you for watching.